So overall, today here with me is Steffen. Steffen is one of the main developers of MZmine currently, mostly working on like IMS and like timsTOF data and so on. So if you're interested, you should definitely reach out and see why like some other tools don't work that good on that type of data. But it's it's very complex. So he's definitely the expert on that. And then myself, I'm at Peter Dorstein's lab in UC San Diego, and I'm also shared with Tomasz Pruska's lab. Tomasz Pruska, some of you know him from MZmine2, like he was the guy who actually like redesigned the whole thing. And then we have Tito, also from Tomasz's lab in Prague, and he's also gonna like walk around as an expert of MZmine, and if you have some questions, you can ask him, and he's gonna help you get everything set up and running. So first of all, who already tried MZmine3? 3. So put 3 fingers up. All right. So it's okay. That's not so many actually. It's like barely half, maybe less. Who is still using MZmine2? Yeah, don't be shy. I know some experts who are using MZmine2 still because it just runs. So yeah, okay. There's some, and then there's also some people who never use MZmine. So that's great. And oh yeah, that was not the question. That was just the other people. So the whole project started in 2004, and there was like a poster from Mateo Orisic lab, and then later on was published first. And only when Tomasz Pruska came to the project, it was actually modularized. And what we know for like a long time, like 2010, was this around, and it actually drove the data analysis for many people. And also around that time was when we got like very nice open data formats that we already talked about. And with MZmine3 now, and can you hide? Oh wait, I have to do that. With MZmine3 now, we completely redesigned the project. We made it more performant and also like remodeled the whole user interface. And I hope to show you that this is like a huge effort by many institutions. So it's not only us, we're only representatives here. There has been over the last like 20 years, has been so many contributions by different people and different institutions. And just to name like a few, Tomas already talked about. But so we usually love those environments here. And I think you already got like a glimpse of what's still ahead of us. It's just nice that we can interact directly and that we can have some coffee together, speak about your issues, your problems, your ideas, and maybe some of those ideas will make it into the software because we're inspired, or maybe we inspire you to also contribute. And that's actually true for all the open source projects. Even if you're no programmer, you can always contribute. Like there's documentation to do, there's ideas to give. And so I think it's very important to just interact between developers and users and the power users. So now to MZmine3 and to the data in general. We already saw like a glimpse of the data that we acquired, and this is not it, but it's just like a 3D view on mass spec data. And what people usually look at is, of course, we have retention time as the first separation dimension, and then we scan with a mass spectrometer very fast mass scan. So we have the mass to charge ratio and then the intensity. So it's a like 3D data set that we have to make sense of. We have to extract features from, and many then think and want to have just like one data table where they have just an answer. Is leucine, is this compound, and nothing else, and then the intensity across like your study. So like all the samples and sample groups. It's not going to be that easy, I can tell you, and you shouldn't trust software tools just providing you any like annotation just out of nothing. You should definitely like double check. We're still at that point, I would say, but the tools are getting better and better, and hopefully also more user friendly. But it's good. Experts are still needed in this field, so you're safe. So there's a bunch of different tools, and we're only going to focus on MZmine3. But as I said before, yesterday, There's many other tools, and it's good that we have like different ecosystems and different languages, and we also collaborate with those other tools. Like we collaborate with people working on XCMS. I know Hiroshi Tsugawa working on MS Style. So it's very an OpenMS, of course, but it's very nice that we have this like very open interaction between the tools as well. And then, as I said, we're not gonna give you like a black box that's just producing your like nature ready to print graphics and results. It's more like like a tool set. You're gonna see there's like so many buttons and menu items and everything that we have to go through. But that also gives you some flexibility in the processing, because everyone comes with like a diverse background scientifically, but also from the field you're working in and the data sets. And we actually just want to give you more tools to make sense of your data. And so now the switch from MZmine2 to MZmine3, why? Like the few people still happy enough to raise their hands for MZmine2. I would say I went back to MZmine2 to just do like a simple analysis, and it was pain. And I love the tool, like it's so nice. And it was like one of the most user-friendly in that time, like 5 years ago. But now, like with MZmine3, it's actually so much more streamlined and so much easier to work with, and also like the performance and everything improved. So I would say definitely give it a try today, and then maybe use MZmine3 or any other tool that you like, of course. So we're going to run you through some feature finding in MZmine. But before we do this, I'm actually going to cover most of the data visualization part in the beginning, and then Stefan's going to take over, run you through all the individual steps that you see here. I'm not going to tell you about it now. So let's open MZmine3. I hope you all installed it, as we said in the email. There's a link that we send out to download MZmine3. If someone forgot to download install, it's maybe best to stick to your partner, your neighbor, and then maybe redo it like later on. But so when you start MZmine3, on the different platforms, we have installers. You have to basically say, hey, I trust MZmine3, then it installs. Especially on Mac is a bit weird because you have to kind of say, like, I really trust this software, and then you install. And then you can just directly open. But we also have some portable version, so you can also run there. Did everyone start MZmine? Because I'm just going to go ahead for now and say, now locate your data, and you can grab as many files as you were able to download so far. And
except the not ready files.
What?
Except the not ready.
Oh yeah, except the files that are not downloaded yet. So, and then I can just drag and drop them into MZmine. And if I do this, it's directly going to import. It's using the MZML import. And you're going to see, like in MS data files, you can see all the files here. I actually forgot. So, okay. Tell me if everyone, I guess you can.
Always like instantly download.
A minute to import, or okay, one thing is you really also have to think about where you store the files. So if someone's, for example, storing it on your university cloud or something, even like the desktop on your computer sometimes, I mean, not for your laptops here now, but if you have a laptop, a desktop at your university, it's very often like a user server where it's stored. So it's not actually the local computer. I would always put stuff on the local computer on an SSD, like fast drive and import. Should be fast, but it should be like, at least this version should be like a few seconds to import.
It also depends on your machine. Like if it doesn't have as many processing cores or so, then it takes a bit longer to import. But yeah.
Yeah. And of course, if you accidentally picked up the raw files, which came from the instrument and our profile, they are a bit larger, and we use like internally a parser to like import them. So it's a bit slower, but even those should be imported in like a minute at maximum. So at least for everyone who already has one file imported, you can just start like double clicking on a file. Okay, so you can double click on a file, and if you do that, it opens up the raw data overview. Yeah. Okay. All right. All right. That looks amazing. Like, come on. Nice. You managed to? Nice. Okay. I know that most people are fine, I think. Sorry? Oh my God. How did you do that? But so yeah, so I saw like some people were still connected to Massive, still had like this folder open, couldn't like drag and drop it. But there's like a couple of things. And as I said, usually make sure the files are in like the fastest drive you can get. So like the SSD in your computer. And sometimes it's pretty weird, especially in university networks. You can have, as I said, like a user that like has the desktop, and then everything on the desktop is on a different server, not on your computer. And it's just like mirrored and stuff onto there and linked. And so at least I had some people having problems like years back with that at my university. And then one thing, like who's like seeing this message up here? Like a lot of people, right? And so it says that my temp folder is actually on like a user folder, and not in like the public, in a public folder. There could be a problem if you have a data analysis computer and there's like 10 different users using this thing. On Windows right now, we have a problem that the temp files are not being deleted because it's only deleted at the next startup of MZmine. Yeah, it's an internal issue with Java, and there's already like a bug report for that. But so we can't do anything about it in MZmine for Windows. But you can change the folder here. So I click on change, and then it directly jumps to the temporary file location, and I see it's the user. And so I can just click and change. And for this, I'm just gonna put it here to like MZmine temp or something, just to make sure that on a folder that everyone can access. You know, so every user otherwise has like a different folder, and it's just like spamming those temp files. And here, everyone can like use the same folder. The temp files are cleaned up more often, and it's done. So I just do this and OK, and OK. And then it tells me, I didn't see that because my computer already has it set up. It says our executable path is not set properly, which is a bad issue. We have to fix that. So I have to go. Yeah, that's what I want to say next. There's a different way of getting there. So let me fix that first. There's like general, and then there's like a RX. Why is that? It never came up for me. Okay, I don't have to set it up. Okay, so usually you can go to project and set preferences. And I also want to highlight that this is actually important. There are like plenty of different parameters that you can set up here. For example, you can set up the format for MZ values, retention time, intensity. And this is very important because it's used for visualization and also data export. So you can set up here that you want to have like more precise or less precise visualization and export of data. So, and then on general, you can see the number of CPU cores is usually used as the number of threads that are going to run concurrently. And if you want to set it higher, if you want to try something else, or if usually there's also other tools running in the background and you don't want to overload your computer, you could also say, I want to set this manually to something lower or higher. But usually it's good to just stick to the cores. But definitely important, just change the temp file directory. And also make it so that it's on a very fast drive. Yeah, so because it's temporary, we use those temporary files to store spectral data on disk so that your memory is free. Yeah, so that we can use more memory for actual processing. Okay, so if everyone's done that, you can just come back, import all your files, and just if someone had problems to drag and drop, you can also go for raw data import, and then MS Data Advanced is usually the easiest way. So I click on that, and then here I can also select all MZML files in all subfolders, for example, and then I can just click on the workshop folder, and there's some internal folder structures, and it's just going to pick up all the MZML files. So if you wonder like what all the MZML files are on your computer, you can just do that and import. So that's a different way to import. Just make sure that the advanced import is deselected, which it should actually be by default. But yeah. And then you should end up with all the files here. And I said you can double click on the file. So again, I'm just going to double click on one file. It pulls up a raw data overview. And in here, I can click on like any part in the chromatogram on the left side. So the chromatogram gives us the retention time, and then like trace of the base peak intensity. We can change that in some of the parameters. I'm not going to do that here now, just so that you know. you can visualize either the TIC, so just the sum of ions that were detected at every time point, or the base peak intensity, which is the highest ion in the spectrum. And also, you're going to see the highest ion, for example, in this spectrum was the 304.15. So if I go into the spectrum by clicking, we can see this is the main masses here in the spectrum, the 304. We also see a natural 13C isotope pattern. So if you can see like the 1.003 distance between those signals, that's the 13C isotope pattern. And I can just click through and look at like different spectra. And I can also look at different distributions. And of course, because we have the 13C isotope pattern originates from the same compound, it's going to have the same feature shape when I click on the signals. So the top one is, of course, the base peak. So it has the intensity of the chromatogram here. And then the lower one, if I click on it, you're going to see the same shape, just lower. And the same is true for the other peak. Yeah, so you can just try to navigate a bit through the raw data, get like a little feeling about it. And if you actually want to compare some samples, because I accidentally actually clicked on the PPL, which is the processing blank, if I'm not mistaken, right? So, and then the other samples are actually the samples that are like this dissolved organic matter. If I click on this little checkbox on the raw data overview on the top left here, I can now actually select multiple files. And you can see that the color on the side of the files actually represents the color also used in most of the data visualization. And we can already see there's a lot of differences as expected for the blank and one of the samples. And if I now click somewhere, I can actually see the spectrum here. And it's of course very different. Like we can't see many of the like black signals. They're kind of hidden behind the other ones. But even if I zoom in, there's only like little in the processing blank, whereas the dissolved organic matter samples are very complex. And again, I can just go through and kind of click on different masses here. And it's actually going to extract like the base peak chromatogram of this mass again.
Robin,
yeah.
How do you zoom in and out of the charts?
Oh, good question, Steffen. So there's like a very natural way to it with your mouse. You can, first of all, draw like a box to zoom in. You can always draw a box in the other way to zoom out, or, which is pretty nice, you can go and then double click on the axis to auto scale. So if I double click on this or double click on this, it's going to scale. Same is true for most of the charts in MZmine. And also you can hold control, for example, and then use your mouse wheel to zoom in. So if I zoom in on the axis, I can just hold control, zoom in. And with shift, for example, it's also auto scaling, which might be more if I'm like here. It's always like auto scaling the signals if I'm holding shift down. But in general, like with any tool that you use, just try all the modifier keys and try your mouse. Like sometimes it's actually smart, and there's some ways to better navigate your data. And we can also look at, of course, multiple files. And in those multiple files, we can already see that, at least for the samples, a lot of these signals have the same retention time and kind of the same peak shape. And if I click on it, it's also extracted, and we can see it's extracted here for all the samples, kind of like overlaid. And this is the signal here in all the scans. And I think this is like a good way to first start interacting with mass spec data. So you can like interrogate what is the retention time of one of the specific compounds I'm interested in, but you all can also look at the retention time difference across your whole sample set. This is a small sample set, and so it's easy to do that. If you have a bigger data set, of course, it's usually good to just sample through like your, let's say like 100 files or 200, 1000 files, you just go through and pick some of them and do it maybe like visually in the first place. But then later, of course, you have to find some statistical means to extract this information. And
one thing to add is the more files you have selected, the longer the processing for like the chromatograms and the scans will take. So
yeah,
if your computer isn't that powerful, then maybe just select like 2 or 3 files.
yeah. It's usually also not as informative at one point.
Yeah.
That's interesting. So, oh yeah. So it's always like the checkbox. If you see it on those tabs, you can like click it, and then it should like update to the data files that you select here. Of course, you can always double click and open a new one, but this is kind of a nice way to limit the tabs. And then also one thing down here, you also have the scan list. And here we can already look at, if this was not your data set, you can actually also use the scan list and kind of go through and see what type of analysis it was. And so in this data set, we can see it does a MS1 scan. And then afterwards, we triggered 5 MS2s. So that usually means it's like data dependent acquisition, maybe with a top 5 DDA. Yeah. And okay, and good. Okay, and yeah. No, not really. So the thing is, in the first place, when you acquire data, at least on like the thermo instruments, you can add like a description and so on. And this description is usually also passed on to the MZmine files as some metadata. Most people, as far as I know, most people just don't do that regularly. And also, it might even be like a good way, you know, as we discussed earlier, you push your data to massive. You can make a public data set in the first place, like directly, and just don't add too much metadata if you're not feeling comfortable sharing it before your publication is out. But you already make your data kind of visible, and people can find you and also find that you're working on a specific problem. And you can also leverage the tools that we built that use the repository scale data. Yeah. So, but the metadata is usually pretty limited in the MZmine files. And just later on, we also going to focus more on the MS2 scans. And if we now just go to any data point here, any peak, if I click on it, the table directly jumps to that location. And beneath, you can see for this time point, we triggered 5 MS2s. And I can basically go through all 5 and kind of look at the MS2 spectrum on the right side, and also see the quality, or how many spectra actually were triggered and signals. But a better way to actually see your coverage of MS2 scans for the file is when you go to visualization, and then the MSMS scatter plot. And this is the second tool that I would like to highlight. Is very nice if you want to look at your data and data quality. So if I click on this, I usually just click on auto range for the retention time and the mass to charge ratio. We can type in a larger MZ tolerance. MZ tolerances are going to be important later on in the processing. And for this instrument, you will always hear that you usually should have below 5 ppm mass tolerance from the mass, from the exact mass that is calculated to the accurate one that you measured. But we're going to use different MZ tolerances throughout this workshop, and we're also going to explain why. in this case, it's only to match the MS2 to the MS1. So we do this, and then up here we can change to the precursor INMZ and retention time. And if you set it up wrong, you can change it in the next view. So if you have this, so retention time, precursor INMZ, auto range, and just any MZ tolerance here, you can click on OK. Oh, okay, I didn't know that. Okay, we have to run one step first, sorry. Can you go on mass detection and mass detection? No, you don't have to select all the files. We can do it in a different way. So if you just click on mass detection here, this is usually the first step that's always done in MZmine. So it's on raw data files, mass detection. We already did the peak picking during the conversion, right? Very often you're going to acquire profile spectra, and then we convert it to centroid spectra. And then in MZmine, we can add another threshold, or we could also do the centroiding. So in the end, we definitely want to work with centroid spectra. So if you do that, we can select the centroid mass detector, because this is the data that we have. It's already centroided in the MS convert. Yeah, it's basically this. So we don't have a profile peak. We have a centroid, so one MZ in intensity for each ion that we detected there. And then we set up, and we're just going to set it up to 1E5. We're going to optimize this like in the next step, but I just want to show you one thing. So 1E5 and OK. And you can select here the raw data files you want to run it on. Either it's the selected, if you selected all the files, or you can also just use all raw data files. Oh, and then for now, we can clear the filters. So we're just going to apply this to all spectra. Okay, so very easy. It's all raw data files, all. So we clear filters, and then centroid 1E5. Okay, everyone got that? And you click on OK, and it's already done. So it already went through all the scans that we acquired, and now we have like centroid thresholded spectra. Now I try to open the MSMS scatter plot again in visualization and set it up to retention time and all those parameters here, and OK. And now we're going to see that it is visualizing on the retention time axis and precursor ion MZ axis. It's visualizing all the MS2 scans that were acquired for this sample. Okay. Oh, there's the scatter plot, and there's the MSMS scatter plot. But the MSMS scatter plot should be. Oh, yeah, maybe you have to select one file. Maybe I just did that automatically. So this is a view that only looks at one file. It's good. It's the first time that I'm showing it at a workshop, so it's kind of interesting. I usually go for myself. I usually do like a different processing, and then. So you select one file, and then select it like this, and just open. So everyone who already got it can like look through the charts and try to understand what it means. And everyone else, I just leave the parameters for a minute. Yeah. Oh, yeah. Yeah, it's good to know. We set it to 1E5, but at least for this step, it doesn't actually matter. It's only like everything in MZmine uses centroid data, and so we usually rely on the mask detection step first, which only takes like a second to run. So it's even on like thousands of files, it's like an instant. So. Okay, so I know that some people are still trying to open it. So it seems like we need to make it more fail-proof, but select one file and then the MSMS scatter, and then open to see the precursors. I just don't know how you do it. So if you import them as like files, they're going to have 16 profiles there. Then we do have the master detection step, which is then getting very important. Because otherwise, you get like 1,000 data points.
Yeah, okay.
Okay. Well, that's interesting. I never had any problems with this module. All right. All right. So I guess everyone got it, kind of, or a neighbor who got it. So yeah, we definitely have to make it more fail-proof. I'm always doing it one way, and that way works. And now I know we have to run some like mass detection and so on. But I have to stress that like all the modules in MZmine usually run on data, and you have to run mass detection first. So mass detection, Stefan's going to guide you through that, is usually always the first step, because maybe you still have profile data or you already have centroid data, but we usually want to denoise. So we usually want to set a threshold to like remove some of the noise. And then, so if you open it now, you can see that on the X we have retention time, and you can change that, and then precursor ein MZ on Y. And so this means like all the little scatters that you see is MS2 scans. And we have a top 5 DDA method here. So we're like very much focusing on MS2 acquisition. So it's good to look at the pattern that we acquire across those two parameters, those two values here. And I can already see if I also click on the X here again, or like if I check the top, if I now open the processing blank, there shouldn't be too many abundant signals in there that trigger MS2 scans. So there shouldn't be such a variety. And we can already see if I just zoom in, again, I can drag the axis. If I zoom in, we can always see those patterns, that there's just like one ion being fragmented like over and over again. And that looks pretty bad, right? But it's a blank. So first of all, this is a blank. It's okay if there's only like few masses being fragmented. That just means it's not very dirty. It's not very contaminated with a bunch of different ions that we detect. At the same time, maybe I should see if I could exclude this mass to charge ratio is like 163, well, like 62.9 something. So that's like even like a very, very off number. This is usually like no small molecules have this mass to charge ratio, unless of course there's like very little hydrogen in there and a lot of like different oxygen, nitrogen, and heteroatoms. But overall, we can also see the dynamic exclusion working. So we trigger one MS2 here for this mass, and then we exclude it for some amount of time. Yeah, so we don't trigger it, but there's another ion just taking its place, being fragmented, and there's a bunch of other ions being fragmented in the meantime. So in the end, if you only have like 5 abundant masses, you might still end up just fragmenting the same thing over and over again. But going back to one of the real samples, we can already see, just looking at it, it's way more distributed. So there's more different masses being fragmented, and there's also way more masses being fragmented, not on like a straight line, but a bit more like scattered across the retention time and MZ range. And still, I would say like the vendors should, or like all of us, but specifically in the acquisition software, we still have to be smarter in the way how we acquire MS2 spectra. So this is still an outstanding challenge. There's some ways to do it more on like a data set level, to say, okay, I already saw this MS2 spectra now like 3 times. I'm not going to acquire the same thing again. But still, you're going to see some redundancy. But so this is one of the data quality measures that we can look at. And then we can go back to the raw data overview to then optimize the whole workflow. And I don't even know how much time.
10 minutes. So I guess we start after lunch break with the workflow.
Yeah, maybe. How long is when is the lunch break over? Okay. Yeah. So maybe it's good. Yeah. So I would say everyone who's interested can still deep dive into the data a little bit. And then after the lunch break, we go through all the processing steps and then get the files ready so that we can do some feature-based molecular networking and other things like in the next days. We're gonna like be here. You can ask some questions about the specific data or MZmine. and then we can see each other after the lunch break. So yeah.
From your perspective, like programming perspective, what would you like to do, like consumers of the data, that comes from the 5 scans, or maybe 10 scans or 50 scans? You don't care how many scans we do, or is it something your software like crash if it's too many things for?
So you mean like scans like MS1 data points? Yeah, yeah. I mean, I just want to stress that it really depends on like all the parameters and also what you want to get out of your data files, right? I mean, we all learned that more data points on a peak just makes it way easier to actually detect this as a peak and extract this information and also filter out noise, because there's like some masses that are just like distributed, let's say in your eluent, you have in your ACN, whatever, you have some contaminants, some plasticizers and so on, and they're just like there all the time. And if we can't have like much to discriminate those, we definitely going to pick up more noise. So I would say, especially for identification workflows, where you want to do molecular networking, you want to have a lot of MS2 spectra to identify and to connect things. Yeah, you want to go for top 5 for something like this. And then you end up with like 5 data points maybe on the MS1 feature. But just expect that the data processing is going to be a bit slower. It's going to maybe kick out some features in some samples. But honestly, if you have like, let's say you have like 10 samples, like now we have 10 samples, we only need to detect it in 1 sample above a certain threshold. And then we can use this information to go back into the other files and then search for the missing information with a bit more loose settings, you know? So we can have a first feature finding that we're going to do is a bit more strict and runs very fast without like performance constraints, but we miss a lot. And then later we're going to fill in the gaps and we're going to like find the missing features. This is what I would typically do there.
So you mean like from the MS1, you have 1 mass, and then like this one was maybe fragmented, like one run, but not the other. And you can take information, retention time, say, okay, this peak is the same one as the other one, and then you have the same information.
Yeah. Yeah, so it's basically you have like one non-targeted workflow where we do feature finding. We also, like in MZmine3 at least, we are like for all the filters, you can also set up, I don't want to filter out features if they have MS2, because if the mass spec thought it's something valuable, why should I like throw it out, right? So we can keep more things that don't really fit into the constraints of like shape filter and stuff like that. And then later on, we fill in the gaps that we have in our matrix, in our like feature matrix, in our table. We can fill in the gaps like in a targeted way, like semi-targeted way. We have information from the first run.
One thing to add there is it's not just about the number of MS2s you take after an MS1. It's basically around like about the whole duty cycle that you have. So if you have like high resolution your MS2s and you take 5 MS2s, you might still end up with a duty cycle of 5 seconds on an Orbitrap because you just took so much time to acquire those individual MS2s. So you should always think about, okay, how long does one cycle take in the maximum amount of time? And then like, place your number of MS2s you take with the peak shape that you have, like how broad the peaks are.
I'm asking a question, you don't answer it now, but I'm wondering, you're now showing something how to do peak finding and gap filling. Actually, yesterday showed us the workflow where he's also doing these things. Are you going to discuss with us at some point? Is it based on the same principles, or are the principles different, and do they have pros and cons depending on what kind of data set you have? Is that something?
No, I would say it's like alternatives, and there's like, as I said, there's multiple feature finding tools, and in this workshop we said we're going to concentrate on one feature finding tool to kind of keep down the redundancy, but we also wanted to share that there's other tools and also workflows. And I think that's like also the take-home message, that you can put those tools into workflows and work with the export files. And it's very easy to make up those workflows and stitch together tools that you want to use. And especially OpenMS, for example, is very strong on metabolomics and proteomics. Like for MZmine, we don't have that many tools in there for specifically for proteomics. Yeah. So, and then maybe some of you have better chances to process through OpenMS. And it's just important that people know there's different tools.
Yeah, but that's one of the things which I find interesting to say. If you have MS and proteomics, then probably OpenMS will be
maybe, yeah. Yeah.
Like at the end of the week, at some point, give some directions, or whether there are these kind of general recommendations.
It's pretty hard. And as I said, for proteomics, for example, I would say that, well, if you want to combine it, it might be the OpenMS. There's MS-Dial, for example, and was designed for MSE data, so the whole ion fragmentation data. And I would definitely, for that, I would check out this tool first, because we don't have the whole workflow in there, because no one of us is working with that. We're interested in getting it in there, so if someone wants to contribute, but yeah.
A little bit behind the like IMOV data, for example, are not supported. We can make one slide with whatever we can, because really the algorithms of MapAlign are pretty much
Yeah. And also, we can put together a slide that's maybe our point of view, but then maybe in a month, we're going to have proteomics in there, and it's going to be blazingly fast and nice. But software changes, luckily, and so you always have to keep up just trying stuff, I would say. But that's why the common concept that we're going to show is very similar to any other tool, and you can apply it there. So it's just here we have a graphical user interface. We can inspect the intermediate results, and I think this is one thing that people in using MZmine2 already really liked it. That you can see each individual step in results, and you can go back there and say, wait, resolving the feature shapes didn't work, or the alignment didn't work, and why. So yeah, but I guess it's time for a lunch break, and I'm not hungry, so I'm gonna stick around a bit here and then eat a little bit later. So if someone wants to talk, you can also come.
Yeah.